It's the 27th of December. The asteroid terrestrial impact La Salle system in Chile discovers an approximately 50 meter or 164 feet wide asteroid, and it quickly triggers the automated asteroid warning systems. According to its calculations, 2024 YR4 had a chance of impacting Earth as early as 2032. This might not sound like a big deal, as different space objects make near-Earth travels all the time, but this particular asteroid became a top priority for space agencies almost instantly. Now, both the US and Europe are pooling their resources to further analyze the asteroid, even using the James Webb Space Telescope to study it. And they already have an idea of how dangerous this situation is. For those who don't know, the Torino Scale is used to categorize the threat level of near-Earth objects from 0 to 10. 0 either means there is no chance of collision or the asteroid will burn up in our atmosphere. 10 means the asteroid has a chance to destroy human civilization and the future of life as we know it.
70% of life on Earth 66 million years ago was probably only about 10 or 14 kilometers across. And in fact, we know an asteroid as small as 1 kilometer across, if it hit us, would cause global devastation and significant death around the world within a year, because it would throw so much stuff up into the atmosphere, we would get instant global cooling, we'd have crop failures, food shortages, and people would die. A lot of people would die. It's not just the immediate, the problem with asteroids like that, it's not the firestorms and the earthquakes and the blast waves where the asteroid hits. With an asteroid 1 kilometer across or larger, it's actually the material that's thrown up in the atmosphere that causes a global effect.
So, where does this new asteroid sit on the scale? 2024 YR4 is currently at level 3, the second asteroid in history to ever reach this level after Apophis. Initially given a 1.2% chance of hitting Earth, the asteroid gained even more attention when further calculation raised that chance to 2.3%.
The good news is that as of today, there's hardly any chance at all now it will hit the Earth. On the 22nd of December in the year 2032, it will pass close to us, but the chance of it hitting the Earth now is really, really small.
Let's assume the worst case scenarios and make that probability 100%. What's at risk here and how big would be the impact? According to NASA's estimates, the impact of this asteroid could generate a blast equivalent to 8.4 megatons of TNT. As a comparison, Little Boy, the nuclear bomb that was dropped on Hiroshima, had a yield of only 15 kilotons. That means 2024 YR4 is equal to around 565 little boys. If an asteroid of this size was to hit New York, it could destroy the entirety of Manhattan, and its impact would be felt 50 kilometers or 31 miles away from the impact zone. So it might not be a planet destroyer, but it can easily take out a city. When there is a threat of this magnitude, one of the first courses of action is to create a risk corridor, trying to pinpoint the location where the asteroid might hit. The current risk corridor at hand, created by the International Asteroid Warning Network, is this. It starts in northern South America and then moves across the Atlantic Ocean to Central Africa. It touches a corner at the Arabian Peninsula and goes towards the northwestern Indian Ocean and then to South Asia. So the countries at highest risk are Brazil, Nigeria, Ethiopia, Yemen, and India. The worst case scenario in this situation would be the asteroid hitting either Nigeria or India, as they are most densely populated countries on the list. But if this asteroid were to be confirmed to hit Earth, what would be the global response? Would there be an attempt at destroying it?
Over 20 or 30 years while I've been involved in this field, there's been any number of ideas of how to deflect asteroids and how to move asteroids and do something to help protect Earth. We've got three main ways we could move an asteroid, and it depends on how big it is and how much warning time we have. So if it's a small asteroid and we have a long warning time, many years, then we could in theory use something called a gravity tractor. And I don't know if you've heard about this. Let me get an example asteroid. See, there we go. Here's a piece of asteroid. Okay, this is a meteorite. So it is just a piece of asteroid that's already fallen to Earth. And the idea is with a gravity tractor is that we hover a spacecraft. The laws of physics and Newton's law of gravity tells us that although the force of gravity from the asteroid is pulling the spacecraft towards it, the spacecraft's mass and its gravity will pull the asteroid in that way towards the spacecraft. Now, unfortunately, of course, the asteroid is generally much bigger than the spacecraft. So really what's going to happen is the spacecraft will move much faster towards the asteroid than the asteroid moving towards the spacecraft, and it will hit it. So what you have to do is you have to keep firing your rockets. You fire your thrusters and keep the asteroid and the spacecraft separated by a small distance. And it might only be a few hundred meters. But as you keep it that way, what you do is you gradually pull the asteroid into a slightly different trajectory, just using gravity as a tow rope. And that's a really clever idea. Our problem with that is that because of the size of spacecraft we can launch into interplanetary space right now, and with all the fuel on board, we could only do it with a very small asteroid, and we haven't tested it yet. There's another option, of course, which is that we could do something like they do in Hollywood movies and TV and use a nuclear weapon, except they always get that wrong. In the TV and movies, they say, let's use a nuclear weapon and destroy the asteroid and explode it. We would not try to do that. That's difficult, because what you would do is you'd shatter the asteroid, and instead of one big asteroid coming towards you, you have a few slightly smaller bits of asteroid all coming towards you, which is even worse, I think. So what you do is you explode a nuclear device, a nuclear weapon, just off the surface of the asteroid, and that vaporizes that whole face of the asteroid, and that vaporized asteroid goes that way, and Newton's third law of force means that the asteroid itself has to go the other way. And because of that, you move the asteroid. Now, in theory, that should work. Our problem is that we really want to avoid putting nuclear weapons into space, because since the year 1967, there has been an international treaty which, as far as we understand, everybody, all nations on Earth have kept to, which says you do not put nuclear weapons in space because of not only the risk of them being used in a war, but the risk of accidents. And so we would not like to do that.
On January 27, 1967, a joint meeting of Gemini and Apollo executives was held in Washington, one of several efforts to pass on to the Apollo program the benefits of the knowledge and experience gained in Gemini. While the joint meeting was underway, not far away, President Johnson was signing the recently negotiated space treaty, whereby the United States and over 90 other nations agree that outer space, including the moon and other celestial bodies, is the province of all mankind, not subject to claims of national sovereignty.
So then there's the third option, which is the kinetic impactor, which is where you've got your asteroid and you take your spacecraft and you send it on a kamikaze mission at high speed directly into the asteroid, and that pushes the asteroid into a new trajectory as well. So those are the three options we could do. Now, that's if you've got time. In planetary defense, there is a fourth option, which is evacuation, because an asteroid the size of 2024 YR4 would not cause global effects. The effects would be limited. The effects would be devastating near the impact site, but it would only stretch a few tens of kilometers around that site. So if we can predict where the object is going to come in, and we do not have time to launch a deflection mission, we can simply try to evacuate everybody from that area. And that actually, to be honest, with some scenarios is the easiest thing to do, and probably the most likely thing to happen. But it depends on how much warning time we have, and it depends on the size of the asteroid, what we actually do.
Currently, there are 3 organizations in the world that have the technology or the resources to change an asteroid's trajectory if need be. In fact, one has already achieved this feat. It might sound like a science-fi concepts seen in movies like Armageddon. Oh, sorry, my bad. Wrong movie. But NASA has already made a successful attempt at asteroid redirection. The Double Asteroid Redirection Test, or DART, was NASA's first planetary defense mission, launched in 2021. On September 26, 2022, DART intentionally crashed into Dimorphos, a moonlet of asteroid Didymos, altering its orbit slightly. This confirmed that kinetic impactors can in fact change an asteroid's trajectory, proving a viable planetary defense method. So, if 2024 YR4 were confirmed to be a bigger threat than initially thought, the US response would be to assign NASA to do a similar thing. But the DART mission was no small undertaking, costing the US $324.5 million, and with all the Dodge budget cuts, it's not certain that saving the planet would be seen as an essential expense by Trump and Musk.
The problem is, as you say, whether or not we would have time to agree to spend the money, because we are possibly talking 200-300 million euros equivalent. We would need to build the spacecraft, launch it, and have it on the right trajectory so it hit the asteroid in enough time that the small amount of push moved the asteroid. And that could be difficult because of the uncertainty and exactly where it was going. A kinetic impactor mission like DART should be successful in moving the asteroid, we think.
The second organization that could intervene would obviously be the European Space Agency, or ESA for short. Much like NASA, ESA has been putting time and resources into studying near-Earth asteroids in order to develop better methods of stopping them. For example, the Hera mission was launched in 2024 as a planetary defense mission designed to study the effects of DART's impact on the asteroid's Dimorphos. Hera will arrive at its destination in 2026 to measure the asteroid's mass, internal structure, and crater size, providing crucial data on kinetic impactor effectiveness. This data will no doubt be useful in the development and refinement of new asteroid deflection techniques in the future, if Europe had to take up the responsibility of stopping an asteroid. The third organization that could complete this mission, and maybe the most unlikely hero in this situation, would be China's CNSA. They might not have the history and the accolades of NASA or ESA, but this world superpower has been showing interest in expanding its space program to compete with Western nations. China is already working on an ambitious planetary defense strategy with plan to test asteroid deflection techniques by the 2030s. The China National Space Administration even announced a mission to track and alter the course of near-Earth asteroid using a kinetic impactor, just like the NASA did with DART. The target asteroid has not been finalized, so 2024 YR4 might make a great test for China's future ambitions in planetary defense against near-Earth objects. After all these theorizing and estimations, you might ask, why would the US, Europe, or China bother with deflecting an asteroid if it's not going to hit them? A project of this magnitude would cost the country millions and millions of dollars. So what would motivate them to undertake such a huge task? And to answer that question, we need to accept an uncomfortable truth. According to the Torino Scale, an asteroid that has a 100% chance of hitting Earth and is big enough to destroy cities and cause tsunamis occurs every 1,000 to 10,000 years.
Asteroids do not recognize borders. They land where they want to land. And so we have to be prepared for an impact anywhere on Earth.
So it might not happen in our lifetime, but it will eventually happen. And this event can prove which nation will be the Earth protector when the time comes. So which one will it be?
please stay in science, because we are not going to solve the problem of asteroid impacts on the Earth for many, many years to come. And, you know, I will retire, most of my colleagues on the Hera mission will be retired, and we need a new generation of scientists and engineers to both discover and track these asteroids, and also send our space missions up to find more about them, so we know what will happen when we do try to deflect them in the future. Because at one point we will find an asteroid that is going to hit us in the future, and we will have to do something about it.